All right, so I'm going to talk about geometry today. I begin with the similarity triangles. If two triangles similar, right? If only if their angles are the corresponding side of angles are the same. Here's alpha and alpha prime, beta prime, and you don't even need to know the other one because the sum of three angles is going to be 180 degrees. Okay, so the triangle, the two triangles, I'm going to use A, B, C, A prime, B prime, C prime. So the triangle A, B, C, this notation called is similar to the triangle A prime, B prime, C prime, if and only if, okay, and the corresponding angles are equal. Okay, now this also equivalent to saying that if this side is A, here's a B, here's a C, okay, and this is a prime, B prime, C prime. So if only if the corresponding ratio, okay, the ratio of the corresponding sides, okay, are equal. Okay, B and B prime equal C and C prime. Okay. Okay, of course you can put a gamma here, then gamma prime, then gamma should be equal to gamma prime. Right, so that is this is about, you can use one of them to define the similarity of triangles, and another one is called the theorem. Okay, and in most of textbooks they use angles to define the similarity of two triangles. Okay, the question is how to use it. Okay, how to use it? Well, if I have two lines of parallel, right? This is a two line. This is a parallel. Okay, then you will see that this angle equal to that angle, right? So I can say, yeah, how to check whether two lines are parallel? Then you need then if this is angle alpha, then if and only if alpha equals alpha prime. Okay. Okay. I assume that we assume this is parallel. Okay, I draw the two lines. Okay. Then what do you see? This is A, B, right? C, D, and E. I claim these two triangles similar. How do you prove that? Well, this angle should be equal to that angle, right? So this angle this angle should be equal to that angle. So these two angles must be same. Gamma equals gamma. Right? A corresponds to D. B corresponds to C. So the triangle ABE is similar to the triangle. We have to use a D, okay? C and E. Okay. Okay. So so you can get the ratio of the corresponding sides, right? You can use a ratio of the corresponding side. A typical example is inside the triangle, okay? Inside the circle, okay? So this is here's a question, okay? This application one. And we, for the circle, inside the circle, okay? If we have fixed 2 points A and B, okay? And you draw, this is a C, and this is a C prime, for example. We have the important fact here. This angle must be equal to that angle. Okay. Alpha must be equal to alpha. This is a fact. Okay, I'm not going to prove it here. All right, so this is a very important observation. Right, then here I put a D here. Okay, using this fact, we can show that those two triangles are inside. Okay, so here's a question. Okay, I randomly draw the two lines. Okay, then I connected this. Okay, right. So this is A, B, C, D, E. Okay, I want to prove that the triangle on the left is similar to the triangle on the right. How to do that? Okay, show that the triangle A, B, E is similar to the triangle C, D, E. Okay, A corresponds to B corresponds to C. So maybe I should use a D. Okay, D, B, E. Okay. Okay, how to prove that? Prove. Okay, because those 2 points are the same point, so those 2 angles must be the same angle. So here's I call it alpha and that R, right? Right, and similarly, those 2 points are the same, right? So this 2 angle must be the same, beta and the beta. So alpha, I see, right? So then this 2 angle must be the same. So that's why B corresponds to C, A corresponds to D. Okay. Use a similarity, then you can the proof. I know I said that the angle at A should be equal to the angle at D. The angle at B should be equal to the angle at C. Okay. That. Now, if I was so if I just randomly draw the picture here, and here's 2, 3, and here's a 4, and what is the other side? Now, some students say, "Oh, that must be 5." Actually, it's wrong. Okay, you have to use a similarity to solve the problem. Okay, so that's called the X. What is X? So you draw the 2 lines. Addition line is important to draw. And these 2 triangles are similar, so the ratio of the corresponding sides will be the same. Right? Right. So we can do that, right? So by the similarity, okay, find the X here, right? Right. By the similarity, the triangle here is A, B, C, D, and E, right? So the triangle ABE is similar to the triangle DCE. So this implies the ratio of the corresponding sides should be equal to each other, right? Okay. So X is going to be 4 times 3/2. So it's going to be 6. Right? Yeah, it's going to be 6. Okay, good job. All right, so now let's look at the following problem. All right, and then we got a little bit more complicated problem here. So this is a square, you're familiar with this whole exercise. So this is A, B, and C and D. Okay, so So A, B, C, D is a square. And it's a rectangle, you can do the same, okay? It's a square, okay? And so what do you want to do here is that you choose a point, okay? This is not necessarily even the middle point. So it's yeah. But let's choose a middle point, okay? Now for some problem, you can modify it. So this is a point M, right? We can even generalize that later, okay? So this is a middle point, okay? Middle point, okay? And this is not a middle point. This is going to be, the ratio is 1, 2, 3, 4, okay? So the equal points. I'm going to, sorry. Yeah, 1, 2, 3, 4. Okay. So what I'm trying to do is I draw the line here, right? And then I draw this line and draw this line. Okay. So I get SR. So I denote this by X, denote by this Y, denote by Z. So what I'm trying to do is I'm trying to find the ratio X to Y to Z. And if you're able to solve this problem, and then you can answer the questions in homework. Okay. So when you see a problem like that, okay, how do you do this? Look at it. You probably have to use a similarity of triangles, right? You have to use a similarity of triangles. All right, so this is a S, right? So first of all, you find the two triangles which are similar, okay? So step one, the triangle ABS, okay, is similar as the triangle CDS. Okay, those two triangles are similar. Let me mark it. Okay, those two triangles are similar. Okay, why they're similar? Because it's a square, it's parallel, right? Two lines are parallel, then you draw a cosine. That's what we did at the very beginning. Okay, so the ratio of the corresponding side, so AB to CD is going to be, right? Is going to be, yeah, BS to SD. Okay, why? Because this corresponds to that side, right? And then this side corresponds to this side. The B corresponds to D. So that implies AB over CD. You know that AB over CD, right? AB over CD is clearly the 5 over 4. Okay, it's a 5 over 4 because you divide one side into 5 equal parts. Okay, but DCs only take 4 parts, AB is 5 parts. So this is going to be, right, ES is Y plus Z, and then over X. So you get the first equation. Okay, then we have a trouble to get another similarity of the triangles. Okay, so that is the second part, is complicated. It's difficult. So I'm going to get another equation. Okay, so let me redraw the picture here. 1, 2, 3, 4. Okay, I'm going to get this. This is a middle point. Okay, so how can I find another similarity? How to find another set of triangle? Okay, now in geometry, yeah, this is a difficult one. In geometry, sometimes you have to draw addition lines. Now this is the difficult part is this. Okay, you extend this line and draw this part. That's point P. Okay, this is the most difficult part. Okay, and why we do that? Okay, and the D is N and the C. Okay, I think my mark is wrong here, S and R. Okay, so let's go up here. This is N. Okay, so another D, this is N. So D is N, I should. Yeah, D is N. Okay. Yeah, so C and S. So BS and SN. CN. Okay. Yeah. All right. So now you have what I'm trying to do is I'm trying to compare uh, those two triangles. Okay. Yeah, those two triangles. And this is a X, Y, Z. Okay, those two triangles similar. Okay, those two triangles similar. Right? So the triangle ABR is similar to the triangle PNR. So the ratio, so AB compared to PN should be equal to, right? Should be equal to BR to RN. and AB, here's the point, AB to PN, how to find this? Okay, how to find this? The right-hand side is easy, right? BR is going to be Z, and this RN is going to be X plus Y. Okay. So the left-hand side, okay, AB to PN. This should be easy to figure out because M is a middle point, have to use M middle point. So when it's use a middle point, those two triangles are congruent. Sorry, this triangle. Okay, those triangles congruent. So that means CP equals AB. Okay, so that means you have a 5, yeah, right? 1, 2, 3, 4. Yeah. So total you have a 4 here. This is a 5 here, right? Here's a 5. So that's why you get AB is a 5, right? And this PN should be equal to 9. Okay, so you get another equation. And that's enough, okay? So let me write down those two equations again. The first equation, y plus z over x is going to be 5 over 4. Okay, and the second equation, z over x plus y equals 5 over 9. Okay, and then you get two, you got two equations, but 3 variables. That's okay. 2 equations, 3 variables. Okay, and you cannot uniquely determine x, y, z. Why? Because you don't know the size of the square. If you know the size of square, you may be able to get another equation, so you can determine x, y, z. Okay. What is another equation? If you know the size of square, well, another equation you can use the Pythagorean theory. Okay. You can get a Pythagorean theory to find the equations. Okay. For example, another equation. If this side is edge is A, right? And just use one of the equations, one of the triangles, and you can get another equation. Okay, just apply the Pythagorean theory to one of these. Okay, to one of these side, and actually here's another equation could be x plus y plus z squared is going to be one side is a squared, right? Other one is 4 over 5a. Okay, so using that, you can you can get another third equation, x, y, z. Then you can uniquely express x, y, z. Okay. All right. So we don't need that. Okay. So what we're trying to find is find the ratio, right? We want to find the ratio. Okay. The ratio, yeah. So you have a, yeah, now you can solve it, right? Yeah, you find a, yeah, that's not difficult. Once you get those two equations, it's not difficult. So I'm going to multiply both sides by 4 for first equation. 4y plus z equals 5x. A linear equation looks better, right? Another equation is 9z equals 5x plus y. Okay? Or 5x plus y equals, Okay, so that's the equation 1, that's the equation 2. Okay, so I can, there's a 5x squared, 5x squared, right? So what I'm going to do is I'm going to do subtraction to get rid of x, right? So I get 4y plus 4z minus 9z left hand side. On the right hand side, 5x minus 5x is minus 5y. Okay, and what I'm going to do is I'm going to move y to the left hand side, z to the right hand side. So z to the right hand side, it's going to be negative 5z, so it's 5z, right? So it's 9y equals 5z. That implies, right? That implies the relationship y to z is going to be 5/9. Okay, right? Yeah. Right. So once you get that, then you probably can find the relationship between x and z. Okay, because using the second equation. Okay. Using second equation, it's a little bit complicated. It's 9z equals 5x plus 5y. And since my 5y is going to be 5/9, okay, z, right? And this is a y, and then multiply by 5 because there's a 5y, right? Y is going to be 5z/9, and you have to multiply by 5. Okay, so wow. So you have to from here you have to solve for, you move you can move this term to the left hand side. It's 9z minus 25/9 equals 5x. So let's simplify it. 81, right? 81 minus 25. It's a 56. So that implies, yeah, I can also use a z, right? So x/z is going to be, x/z is going to be 56/45. All right, so using those two, now you can find the ratio, okay? Find the ratio is like an x, 2y, 2z. Right now, you can say 56/45 to, this is another number, and 2y, right? But the problem, you can multiply each term by 45. So yeah, that will be 25, that will be 45. Okay, so this is another ratio. Okay, yeah, 45, I think it's not a 55. There we go. Okay, I don't know how to get 46, 56. Yeah. Okay, because 81 minus 25, right, it's a 6, right? And the 7, they're 56. And not a 46. Anyway, so my computation is correct, and this is answer. Then you can answer the question in the book. Now, of course, this problem can be generalized to, there are many, You can find and determine the value of x, y, z. If you know the edge length of the square. The square can become a rectangle. The most general case is the squares become rectangle. Okay, and yeah, the square become rectangle, and you know the exact size. Here's A, that's a B, and here's A. Then and you choose a point here. You even know what is this number C, and then choose another number here. What is the D? And then you draw the lines. You know, something like that, and you still can find out x, y, z. Okay, you can find x, y, z. Okay, that's why you can uniquely determine that. Okay, if this side is B and this side is A. Okay, and by exactly the same idea, but you have to find the similarity triangles. Okay, you can. This is a good exercise. You know, sometimes I just say here's a 2x4 rectangle, and then this side is one other side, and it's not in the middle point. It's also one. You know, yeah. So then ask it to find the value of x, y, z. You can do that. Okay. All right. So this is about the similarity applications of similarity. This is a pretty good problem. Okay. Okay. Now I'm going to talk about, since at the very beginning I mentioned the circle problem. Okay, so I'm going to look at another problem about circles. Okay, about circles. So this is a circle, and I have a point P here, and the distance, this is the center. Okay, this distance is 9. Okay, the radius is going to be 15. Okay. So my question is, I'm going to draw 9 segments here. Okay. So some of them may have integer length. Okay, the question is how many of them have integer length? Okay. Yeah, you think about that. You know, when you move these 2 points A and B, right? Smoothly, you know, and at some position you get the integer length. Okay, and by the symmetry, if AB has integer length, probably this position also has integer length. Just exactly, you know, just it's you always most of the time you get a pair of this line segments. Okay, with the integer length, same integer length. Okay. Okay. Do you have any idea on this problem? What I want to say is that the length changes continuously. Okay, continuously. Then what is the shortest one? What is the longest one? Okay, look at the picture again. Okay, and this is center. This is a P. This is the shortest one. It's unique. Okay, the shortest one. Let's call this length as L, right? Length is L. This is the shortest one. We can figure out the shortest one. Here's a 15. Okay, so 15 is 3 times 5. 9 is 3 times 3. So the shortest one, okay, L is going to be, right? L is going to be 4 times it's 12, that's what. So 2 times 12 is 24, right? No, yeah, 3 times 4 is 12. So this side is 12, okay, 12, right? That's the shortest one. The longest one is passing, is a diameter, right? It's the longest one because the radius is going to be 15. So the longest one will be 2 times 15, which is 30, right? So now imagine when you choose, when change A and B smoothly, but keep it passing through the point P, right? The length changes. The length is between 24 and 30, right? So can the length be 25? Answer is yes. 26? Answer yes. 27, 28, 29. Okay, so between 24, there are 5 integers there. Okay, now for each of these numbers, you have a pair of okay. For each of for this one, there is a pair of chords. Okay, with a length L. Okay, right? So that's the total number of course was integer length is 1 is with length of 24, and then 2, 2, 2, 2 plus 2, right? 5. And the last one is the longest one, which is the diameter. Okay, so the answer is 12. Okay. All right, so this is I think that's only 2 problems related to this circle. Okay, now I'm going to ask you to do the following problem. Okay. All right, so here's a rectangle. Okay, a rectangular table is 45 inches wide and 46 inches long. Okay, it's 45 inches, sorry, 64 inches long. Okay, a tablecloth hang over the table 10 inches at each edge. Okay, so this is a table. Let me mark it clear. Yeah, well, just table. So this is table. Okay. Then the tablecloth. Each side is 10 inches. Okay. All right, so let's do this first problem, okay? So what is area of the table. Okay, that's easy, right? Then ask you the next question. Oh, you have Erica, you have a 24 and the 30 question, so I did not see that. So the above problem, 24 is included. I say when L equals 24, it's only one, exactly one there. When L equals 30, that's exactly only one. I count that, okay? So the total number of the segments, line segment, right? It's going to be 1 plus 2 plus 2, 5 of them here, 5, okay? This corresponds to 24, 26, 27, 28, 29, but for each of those integers, you have a pair. Okay. All right, so this problem is easy. The area is just the edge length, right? Multiply them out, right? So be 65 times, right, 84. No problem. Okay. Now, what I wanted to do is that if I know the parameter, okay, of this rectangular area region, okay, we assume that, okay, the parameter of this is going to be, okay, I don't tell you the exact size, I just tell you the parameter. I don't tell you the dimension of this rectangle, okay? So that'll be 280 inches. Okay. What I'm going to do is, okay, sorry for that. All right. What I know here is that it's 10 inches wide. Okay. So I cannot find the area of this tablecloth, but can we find out the area of this of the tablecloth which can outside the table? Okay. So my question is, can we find the area of the tablecloth not on the table? Okay. And what is that? Here's a table. Okay. But I don't know that. I did not give you the dimensional table. Of course, you can use a specific table dimensions to the calculator. The question is, if I change the dimensional table but keep the parameter, do you still get the same result, right? Okay. So Erica has an answer. Anyone else? There are a couple ways to do this from some. The first method is use just add them together. The second method uses subtraction. But if your answer depends on dimension, that means it cannot be determined, right? You can say the answer is it depends on dimension, and the parameter is not enough. Oh, yeah, Eric, what she did is as a direct method, okay? Think about that, right? You draw, right? You have 4 corners. That's fine. So that's 10, 10, right? 10, 10. So 4 square corner. Okay, so the area of the shared region, right? It's going to be 10 times 10 times 4. Okay, plus this double this area and double this area, right? But those are 2 rectangles. If this is called the y, that's called the x. Then we 10 times the y and multiply by 2, right? Plus, other one is 10 times x, right? Multiply by 2. But we know that here's a 400. And we know we can take a 2 out and get 2y plus 2x. But 2y plus 2x is already given, 218. Okay, that's how you solve the problem. That's what she got. Good job. So only depends on the parameter. Okay. Now there's another slightly different way, but same idea, is to you still have to name the variable. This side is x, this side y. Then this side is the x plus 20. This side is the y plus 20. Okay, 20. So the area of the shared region is going to be the difference. Okay, x plus 20 as the area of the larger one minus the area of the small one. Okay, so you end up with okay, you end up with x times y. Here's 20y plus 20x plus 400 minus x and y, and these two cancel out. Then you get same result. It's 10, 2y, right, and the 2x plus 400, and then 2y, 2x is 218, right? Right. 218, yeah, it's going to be 2,180 plus 400, all right? It's 2,180. Okay, so use a subtraction. You see that you just need the parameter of the square, parameter of the rectangle. All right, our next problem will be all right, the maximum minimum problem. So we're going to plan to plant rectangular gardens of the same length. Okay. Side by side with the fencing all around and divided the two plots. Okay, so this is a vegetable garden. I believe that some of your parents are working on that right now. Okay, so total amount of the fencing is 100 feet. You do need a fence, otherwise rabbits coming to eat vegetable, right? Yeah. Okay. This is rectangle. Okay, it's a total length of the fence is going to be 100 feet. Right? So that you can purchase one row of 100 feet. Right. So, but you have to design the dimension, design the rectangle. What is dimension, right? So this side is X, this side is X, this side Y. We have to decide what is Y, right? And so we want, so we know that the total area of these two plots is going to be 336 square feet. Okay, and we also make sure that the dimensions are integers. Why? Because sometimes the fence is a wood fence. For example, you cannot bend it. It's always like a feet, one foot wide. Okay, so this is an additional condition. Now, what is the length of the fence that divide the two plots? Okay, my question is, what is the length of the fence that divide the two lots? Two plots, okay? So basically you have to find X, Y, Z. X, Y meet the soil requirement. Okay. Sometimes you are asked to maximize the area. Okay, that's a different story. We can talk about. You purchase a fixed length of fence. The question is, you want to make the area as large as possible, right? Then you have to determine X and Y so that you have the maximum area. But this is a problem. The area is already fixed. Okay, do you still have a freedom to choose X and Y? Okay, the total length. So you write down the equation. The total length, you have how many Y there, right? You have 3Y there. How many X there? 4X. X plus 3Y is going to be, right, 100. Okay, and the area is 2 times XY is 336. Okay. Can you have a solution for that? Well, you can just, by it's straightforward, right? You just solve for Y, right? You can solve for X by the first equation. It's 100 minus 3Y divided by 4. So it's 25 minus 3 over 4Y. Then you put into the second equation, So x is going to be 25 minus 3 over 4y, and times y is 336. And we're not sure we can have a solution now, right? If we have a solution, then you solve the problem. So you get a quadratic equation, right? You can divide both sides by 2, or actually, we have to still have to in order to have integers, then you still multiply by 2, right? So you still have 100 minus 3y, and then you multiply by 2, this other side of 672. So you multiply this out, you get 3y squared minus 100y and plus 672. Now that's a straightforward. Okay, maybe you find a shortcut and right, and you solve this equation. If you solve this equation, you will get one of the solution will be integer. Surprise! So use a quadratic formula. Okay, use a quadratic formula. It's negative, right? Plus minus y squared, b squared minus 4ac divided by 2 times 3. So after you simplify, you get two solutions, 24 and 38 divided by 3. So 24 is a unique solution. Yeah, I think y is 24, not 7. Okay. Yeah, it's 144 divided by 6 when you choose a positive sign. Right, so 24 is a solution, so y is equal to 24. Now, if we do not, right, assume the area, okay, so what I'm trying to do is that the length of the fence is going to be 100. That's a fixed. Okay. Find the dimensions. So that means, yeah, this is a x, and here's y. Find the dimensions x and y such that the total area is maximum. Right? You want, the fence, costs you money, right? Once you have a fixed length, you have one row of the fence, 100 feet long, right? You have to do some little mathematics. You cannot just, if there's no restriction, how to put a fence there, right? Just rectangular type because it looks beautiful. Then you also divide it into 2 because the other side is maybe you plant the pumpkins and you don't want to, messed up, right? The other side is just as vegetables. So you want to divide them into half equally, and you can move around. You can move it to the left a little bit. But the question is, what is y, right? Yeah, it doesn't matter where you put the middle, actually. The dimension, the area does not change, right, when you move. So there's the other side, this is a 2x here, right? All right, so let's solve this problem. Okay, step 1, you still have the equation for the pyramid. You have a 4x plus 3y should be equal to 100. So the area is going to be 2 times x. So we want to find the maximum area. Okay, of course, x and y are not arbitrary, right? So what I'm going to do is I'm just to either you solve for x or solve for y. It's not a big deal. I can solve for y, right? From here, I can solve for x. X is 100 minus 3y divided by 4. So I'm going to put it here, 2. Okay. So I get 1/2 100 minus 3y divided by 1. Okay, now this is called the area. Okay, so if you draw the graph, what do you see? Okay, this is a y variable and an a variable, right? So you notice that when y equals 0, a 0, right? And when y equals 100 divided by 3, a is also going to be 0. So that means the graph passing through these 2 points. Now, this is a this is a quadratic function. So for the quadratic function, it will be the graph will be parabola. Okay, so graph is parabola and opens downward, right? Because it's negative. So it looks like that. Okay, because the a has like that, -3/2y squared plus 50y. So this leading coefficient is negative. We can spend more time talking about that, right? And now this belongs to, I don't know, 9 squared or 8 squared mass. So graph is parabola. So somewhere in the middle, a has a maximum value. So at the middle point, so a equals maximum when y equals the middle point of those two. So it's 100 divided by 3, then divided by 2, then it's going to be divided by 6. So 50/3. Okay. So only when y equals 50/3, you can get the maximum area. Do I need to know the maximum? I don't need. I just needed to know the dimension. Okay. So when y equals 50/3, then what is x, right? X is going to be 100 minus 3y divided by 4. So 3y is a 50, right? And divided by 4, so it's 1250. So it's 25 divided by 2. So you can get x. So now the dimension is going to be, here's a 50/3, 50/3, and here's 25/2, 25/2. Okay, total you get 100. Yeah, total you get 100. Okay, so that's just use a quadratic, quadratic equation and quadratic function. The graph of quadratic function is going to be parabola, depends the sign of the leading coefficient. If it's positive, it opens upward. If it's negative, opens downward. Okay. Well, there's not much time left. I'm going to discuss the last problem. Okay, this is a regular octagon. Okay, a regular octagon. Octagon, how many sides of octagon? Octagon has one, right? One, I'm sorry. 1, 2, 3, 4. Okay, total 1, 2, 3, 4. So this is an octagon. Okay. The largest square possible is inscribed the regular octagon, means you are going to have a square inscribed here. Okay, this is a square. Okay. And the longest diagonal of the octagon is 20. Okay, centimeters. What is the area of the square? Wow. Yeah. Well, I think that's easy problem, right? Find the area of the square. That's easy problem. if I draw the picture for you, then that should be easy to find out. Right. The reason is, the reason is this the longest diagonal of the octagon, if you're not able to draw the picture, is going to be the diagonal of the square. Right? If the diagonal is a square, then you solve the problem. This side is A, this side is A, right? A squared plus A squared equals 20 squared, right? By the Pythagorean theory. So the area of the square is going to just A squared, which is 20 squared divided by 2. Don't make mistakes. Okay, it's going to be 200, right? It's because 400 divided by 2, it's just 200. Yeah. Okay. So that's okay. Yeah, that is the answer, because those are the easy problems. All right, so we so that's all about the geometry, and next class maybe we'll go back to problems on the numbers. Okay, and if you really have any questions about the numbers theory when you do the homework, please send it to me before the class, not before, and not on Sunday. Do that before the Sunday.